गुड मॉर्निंग स्टूडेंट्स। आज का हमारा टॉपिक है फोटो इलेक्ट्रिक इफेक्ट एंड एक्सप्लेनेशन बाय प्लैंक्स क्वांटम थ्योरी। दिस इफेक्ट वाज गिवन बाय हर्ट्ज इन 1887 और इस इफेक्ट में लाइट ऑफ सुटेबल frequency is made to strike a metal, say cesium, and on the striking of the light, electrons are ejected under the influence of the photons, and these electrons are detected by the anode, which is made the detector. The metal is from which the electrons are to be ejected is made the cathode. So photoelectric effect, the ejection of electrons from the surface of a metal under the influence of striking photons is called photoelectric effect. The observations of photoelectric effect, only photons of light of certain minimum frequency called threshold frequency can cause the photoelectric effect from a particular metal surface. However larger the intensity of photons may be, the threshold frequency is different for different metals. Kinetic energy of electrons emitted is proportional to the frequency of striking photons and is independent of the intensity, and number of electrons that are ejected per second from the metal surface depend upon the intensity of striking photons and not on the frequency. To highlight these points, this is a graphical representation where we have kinetic energy of ejected electron and frequency of light. So before this frequency nu naught, light ejected does not result, light incident does not result in the ejection of electrons. This minimum frequency is needed for the ejection of electrons. If the frequency of light is greater than this value, then you see extra energy is converted into kinetic energy of the ejected electron, and kinetic energy then increases linearly with the frequency of light. Now, this second point, that the kinetic energy of electrons emitted is proportional to frequency and is independent of intensity, can be seen in this graph, that a light of suitable frequency results in ejection of electron and imparts this much kinetic energy. You increase the intensity of light, but kinetic energy remains constant. That means it's not proportional to the intensity of light. Now, explanation of photoelectric effect. The electron is bound to the atom, to the nucleus of atom, and some energy is needed to break this binding energy so that the electron can be freed. So once this much energy is given, the electron is ejected. If energy given is greater than this much energy, then electron will not only be ejected, but extra energy will come in the form of kinetic energy given by half mv square. So incident energy h nu will be resultant in the ejection of electron, plus extra energy will be imparted as kinetic energy. That energy of incident photon, if it is equal to the h nu naught, then only electron will be ejected. If it is greater than h nu naught, then electron will be ejected, plus extra energy will be given out in the form of kinetic energy, and if it is less than h nu naught, then no electrons will be ejected. Overall, the energy of incident photon is equal to work function h nu naught plus kinetic energy half mv square. Now let us do a numerical based on this photoelectric effect. So this is the statement of the numerical. In a photoelectric effect experiment, irradiation of a metal with light of frequency 5.2 into 10 to the power 14 second inverse yields electron with maximum kinetic energy 1.3 into 10 to the power minus 19 joules. Calculate the threshold frequency for the metal. The formula is h nu is equal to h nu naught plus kinetic energy. Nu is the frequency of incident radiation and nu naught is the threshold frequency. So we have to calculate nu naught. So h nu naught को यहाँ रहने दिया, kinetic energy को इधर ले गए, तो हमारे पास आ गया h nu naught is equal to h nu minus kinetic energy. सभी को हमने h से डिवाइड कर दिया, तो वी गेट nu naught is equal to nu minus kinetic energy upon h. इस फॉर्मूले में वैल्यूज पुट करेंगे तो nu naught इज इक्वल टू आ जाएगा काइनेटिक न्यू था 5.2 इंटू 10⁻14 सेकेंड इनवर्स. काइनेटिक एनर्जी इज 1.3 इंटू 10⁻19 जूल्स. h इज 6.626 इंटू 10⁻34 और सॉल्व करके आंसर आता है थ्रेशोल्ड फ्रीक्वेंसी इज इक्वल टू 3.24 इंटू 10⁻14 सेकेंड इनवर्स.